All right. Looks like it might be just the three of us. Welcome to B period statistics for Wednesday, May 13th. After today, we've got two more to go next week, and that'll wrap things up. See, announcement-wise, as a carryover from Monday, I had put in a Dropbox and left, had instructions at the end of class of creating a SDSM, or sample distribution of sample means, similar to what we walked through with the PowerPoint slides and the discussions on Monday. And I was going to kind of go over that with you guys today. However, no one put anything in the Dropbox, so I don't even have anything to critique on. So that kind of throws my lesson plan in a bit of a dilemma. One thing I can do is I can pull it up and I can give you a couple kind of starting points. I'm not going to construct it for you. But it's fair, section 7.2, I was going to wrap up today because 7.2 is real simple, 7.1, but just with a little bit more detail. So I'm at a little bit of a loss to do, and what I'm leaning towards, unless you guys can convince me otherwise, is I'll pull it up and share my screen and go over a few key points on that and have you do it. And I also have a one-page sheet with 9 questions that kind of summarize, or at least challenge you on some of the key points and key takeaways from section 7.2, so we can wrap up 7.3 next week, and I'll wrap up chapter 7. Your thoughts or ideas on all that? Or why no one submitted the exercise for Monday? Anybody?
Yeah, the homework.
Yeah.
I thought I submitted it.
I just checked Dropbox again before we started, and there's nothing on there from anybody.
Oh, I'll email it to you.
Okay.
Yeah, me too.
I thought I submitted it. Maybe not.
I emailed it.
Okay. Do I need to walk you through that, or it was almost identical to what we did in class on Monday, which was PowerPoint, which was actually pulled or derived right out of 7.2 in your textbook. If you've got your textbook there in your room. The only thing that was different was, I think that one used 2, 4, and 6 as the population, and the exercise used 4, 6, and 8. So the mechanics of the thing were exactly the same. Just the population numbers were different, so the calculations were slightly different from the example. Your thoughts, recommendations?
I'll submit it.
What do you want me to? Should I talk you through part of it, or did you do it and without any difficulties? If everybody did it and just didn't submit it, then I won't walk you through it again, or kind of go over some of the key points. If you're lost in the sauce, I'll go back over and go over the key points.
Do whatever.
I need a walkthrough.
Yeah, walkthrough would work.
All right, let me share my screen. Let's see, what do I want? I want this guy. I can move things around. Just a little bit bigger. That's good. Let's get rid of. Oops. Hey, actually, let me go back here. I don't know if I turned the recorder on. Let's see. Where's my recorder? Oh, it is recording. Okay. All right. Oops, that's not the one I want. Darn it. Something else. What's it doing that? Share screen. I want this guy, I think, don't I? There, that's the one I want. All right. So I'm gonna walk you through a couple things on here. All right. It's real similar to what we did in class on Monday. All right. So we've got a population with three numbers, 4, 6, and 8. All right. If I drew one of those numbers out of a hat, the likelihood of one of those numbers occurring is 1/3, right?
Mm-hmm.
For each one of them. So the same thing goes here, right? Goes here, here. Each one is equally likely to occur. No surprise there. Basic stuff. We've done it before. This is 3/3, and that's a 1. All right. Work with me. All right, and the 1 is a big check because the sum of all outcomes has to equal 1. All right. Now this here, we're going to do exactly what's circled there. All right, we're just going to multiply the first two columns times each other. All right. So let me do something here, change something around. Okay. So we multiply the first two columns times each other. This one's 4/3. That one is 6/3, right? Come on. The typing is not working. That one is 8/3, right? Okay. If we add all those together, what do we get? We get 18/3, right? 18 divided by 3. And we get, come on. Some of those columns is 18/3, which can be simplified to 6, okay? And we know that this column is also equal to what?
Mean?
The mean. All right, so no surprise there. And that makes sense. If I add 4, 6, and 8 together, which comes out to be 18, divide by 3, that's the average or the mean, all right? Now, in this fourth column, it's just the first column squared times the second column, all right? So if I square 4, it's 16. Come on. That's 16/3. If I square 6 and then multiply it times a third, I get 36/3 or 12, right? Square 8 is 64/3, right? If I add all those up together, I get what, 116/3. Press it twice for every one of these. If I divide the 116 by 3, I get 38.67. All right, so let me see, rats. So I really need those numbers. I'm going to, and then you can graph this, right? I just got 2, 4, 6, and 8. Each one's equal to a third. I'm going to just do one of them. So 1/3 is what? 33.33. So it just goes up to about, that's 30, and I got 1, 2, that's 33.6. Yes. If I use the bottom line, I get this. And then you do the same thing for that is, let me change that. I'm in the wrong column. We should be over here. We should be at 4, 6, and 8. And all right, so this should go up to 33. Oops, should be right there. This whole up to here, right? This one's the same way. 6 and 8. All those columns filled in. Makes sense so far? Oops. These things really don't want to cooperate. So you got 3 columns shaded in. So we constructed the histogram of the population. This is of the population, right? All right, so let me, I want to keep my numbers here. And I want to scroll up. All right, so there's my numbers here. They're not on the table. All right, so Mr. Gore just told us that second column, or that third column at 6 is our mean, right? So that goes here, right? There was a typo on your sheet there. It left the summation symbol out here and here on your problems. It should be a sum. So here we're calculating the standard deviation of the population, right? So we're taking that sum of that far right or fourth column, 1, 2, 3, 4, yeah, which was the 38, which was the 38 point, what was it, 67, right? And we're going to subtract it from the mean, which was 6 to the second power. I can't do exponents here. Yeah, that's 6 squared, right? So it's 38.67 minus 36, which came out to be 2.67. Right. Just like we go back and forth. Right. We take the square root of 2.67 and we should get 1.63. So that is a distribution or frequency distribution just of the population. All right. That's all side 1. Make sense so far? Okay. Now flipping to the other side. Now we're going to create a sample. Let's see if I get all this in here. Yeah. Oh, I really want to get these 2 tables combined, I think. Let's see if I can do what I need to do. Yeah. All right. So now we're going to create the sample distribution of sample means. All right. So we're going to create every and this is theoretical. We're going to create every combination of those 3 numbers, all right, and then determine what the mean of them are. So we got 4, 4. We got 4, 6, all right, and 4, 8. And then you got 6, 4, 6, 6. I'm not going to do them all. 6, 6, and 6, 8, right? And then we got 8, 4, 8, 6. I'm not writing them all in there just because it's really hard to do this with my mouse pad. And 8, 8. And then we're going to take the means of them, and that's what we're going to, from this point forward, we're just going to operate with the means. So 4 plus 4 divided by 2 is 4. Not rocket science. 6 plus 6 divided by 2 is 6. 6 plus 4 divided by 2 is actually 5. All right. 8 plus 4 divided by 2 is 6. And then we got 4 and 6 is 5. I'm not going to write the other ones in. And you'll see there's a pattern actually developing without repeating myself. It's 5, 6, 7, and 6, 7, 8. All right. So now we're going to deal strictly with this column, because we're doing a sample distribution of sample means. So we're dealing strictly with the means, not with the actual data values from this point forward. All right, so there was a clue here, all right? So we've got nine different means equally likely to occur theoretically, all right? And this is where I'm gonna kind of let you take over a little bit. All right, so let's see here. So how many means of 4 did occur? It was 1. There's only one 4 up there. And there's out of a possible 9. How many 5s occurred? There was 2 out of a possible 9. How many 6s occurred? There was 3. All right, and so forth. And then from that point forward, you're just going to do just like you did on the front side with these sample means, as opposed to the population data that we use on the first side. All right. The third column is the first 2's multiplied times each other, so that's 4/9, right? No big deal there. And 5 times 2 is 10/9, if I'm doing my math right. Okay. And then this fourth column is the first column, just like on the front side, is the first column squared. 4 squared is 16 times the second column 1/9. So this is 16/9. Okay. I'll let you finish the rest. This right here is going to give you the mean. Now, what we talked about this on Monday. How does the mean of the sample distribution, or the mean of the means relate to the mean of the population? How should they relate to each other? They should be what?
Say that again.
How does this mean here, that where I've got that circled, and the sum of this column, which is also the mean, how does that relate? How should that relate to the mean that we just did on the front side of the population?
It should be the same.
Should be exactly the same, right? Because your sample should be identical, reflective of the population. If our sample does not reflect the population, then anything we do with that data is we're kidding ourselves, literally and figuratively. Okay? So that should match. So this value here should match the mean on the front side. All right. Here was another typo. I don't think I put a summation symbol on the problem set download. But here again, it's the same methodologies and mechanics that you did on the front side. It's this column goes right here. Squared goes right there. Right? Now, let's see, what was I going to say? We see, and I'm going to do a little bit. This is 2/9. This is 1/9. So we can see things are kind of coalescing or congregating around 6, right? Which we know then and the whole purpose of doing this is this is going to form a standard normal curve situation that the population did not, because you remember that population just made that perfect kind of square or rectangle box, not a bell-shaped curve. All right. So we know if the data is going to congregate in the middle, we know this number is going to be smaller than what you had on the front side, and it better be. If not, go back and check your work. All right. Any questions so far? The mechanics on the backside are, for the most part, identical to what you did on the front side, which I walked all the way through the front side. All right. Any questions before I clear my screen and I scroll up a little bit, talk about one other key point? All right. Hearing none. here, you're gonna use, you know, here's, let's see. Let me okay. Let's talk about this. So now you're gonna graph, you know, this column 1 is your x-axis. This column 2 is your y-axis, so you're going to graph that, and I can tell you that your graph's going to be somewhere over in here. It's going to be kind of skewed over on the right side. So you're going to do that, all right? You're going to answer this question. And we've already kind of addressed that or talked about it, but I'm not going to just flat out spell it out, all right? Circle the right answer and put it there. All right, now, remember we talked about this is the standard deviation of the means, right? As opposed to in the front, in the textbook and in your PowerPoint slide, it calls it the standard error. At the front, you calculated the standard deviation of the population, all right? You're going to get a value here, right? You get a number here, and we talked about this on Monday. You can get the standard error, standard deviation of the mean, all right, by taking the standard deviation on the front side, dividing it by the square root of n. And n in this situation is what? It's our sample size, which our sample size was 2. We had 2 values in each one of those 9 calculations up on the table on the front page. So what we come up with this here, calculating it this way, which should be identical to the value we calculated here using a different methodology. And as you can see, just thinking back to your Algebra 1, Algebra 2 days, if I keep increasing the size of each of my multiple individual samples, this number is going to do what? This number here is going to do what? It's going to keep getting smaller and smaller. If this number, remember, thinking clear back to chapter 2, this is a measure of dispersion, how far spread out the data is. If I keep increasing this n to 2, or go up to 4, remember all those graph presentations where we kept increasing n, go to 5, go to 10, you know, this value here is going to keep getting smaller and smaller. If this value here is going to keep getting smaller and smaller, you know, from all our discussions, we've kind of revolved around this since last September, October, that if it's getting smaller, that means our data is getting less spread out and dispersed, and it's congregating towards the middle, which then is, again, is helping you form that standard normal bell-shaped curve. So you're going to do that part. Let's see. That's the whole exercise without, you know, I walked you through the front side, and then the back side is for the most part the same mechanics and methodologies. Just do what the formulas and the instructions are telling you to do. All right? Questions on that? Any confusion? Anything I can clear up? Does it make sense? I said, I mean, I wish, you know, we would have gotten farther if we had been meeting 4 and 5 days a week as opposed to twice a week for 50 minutes online. But the nice thing about like chapter 7, 8, and 9 is we're taking all the stuff that we've learned over the last 7 or 8 months, and we're actually applying it and putting it to good use. And it's fortunate, you know, that, you know, we're not here collectively and class and group together, where we can do a much better job of talking about this, working it, analyzing it, you know, as collectively as a class of, you know, 10 people as opposed to, you know, 4 or 5 individuals, each spread out of cubicles and homes online. So that is that. And I'm going to download. Let me stop sharing. Let me pull up another document here. Let's see. I want this guy. Give me 1 second. Okay. All
How many, we get out the next Thursday, right?
Yeah, we just have next Monday, Wednesday together. So let me see. Load up because I won't see you again now for what, 5 days, 6 days. This is really what I wanted to focus on today. All right. This is into lesson problems for section 7-2, and I'll put that on Blackboard sometime today. I'm not be able to do it unless we end class early. All right, and these actually are just kind of a summary of the key points I want you to take away from section 7.2. And some of these you can answer just from doing that previous exercise we just walked through. All right. Some I have some real simple basic math. Again, to reinforce and drive some points home. And I'll put that on Blackboard and just, it should be meeting again next Monday. If you can just, if you can do it, I'm going to put a Sunday evening deadline on it so I can look, or Sunday afternoon deadline on it so we can look at it Sunday night and we can talk about it on Monday. And then we're going to do that on Monday, and then also I'll go through a PowerPoint presentation I'll load up on by Monday class on 7.3 to complete this chapter. All right. Some of these questions are like, let's say like 7, 8, 9, 10, 11, 12, 13, 14, 15. It's kind of the same questions I'm asking you in each scenario with a slightly different situation. And if we always remember that the means of the multiple samples and sample means should be the same means as our population, and that'll help you answer 3 of them right off the bat. And then I'm going to let you take it from there. All right? If I say any more, I'm just going to keep repeating myself over and over. What we can do is I can cut you loose and have you submit this exercise I just went over, which really was due, I think, last evening. No, 9 a.m. this morning. If you get it to me before noon today, I won't gig you real hard for being late. And then I'll also load up that 9 or 10, well, 15, 16 questions. Like some of them are the same question with just a different scenario to do by Sunday evening. And that'll wrap up 7.2. And on Monday, we'll start 7.3 and we'll wrap up 7.3 and chapter 7 on Wednesday. Thoughts, complaints, questions?
Good.
All right, so why don't I end class now? That'll give you time to finish the exercise I just got you kind of set up on. Get it to me by noon. That gives you an hour and a half. You don't have a class at 11. Nobody should have class at 11. If you want to get this thing done today too, and I'll load this up on Blackboard. I could, since I don't have anything till 11, I've got time to put it on Blackboard here in the next 15, 20 minutes.
Good.
So I'm going to start my test later on this afternoon.
Okay.
All right.
Any other questions?
Yes, sir.
And we'll go over chapter 6 test on Monday.
All right. Sounds
All right.
good.
Okay.
Good day, sir.
Bye,
Make sure you get
sir.
make sure you get those 2 things in, and I will see you on Monday morning at 10 o'clock.
Yes, sir.
Yes, sir.
Okay, take care.